Now that we know how to graph cosecant and secant functions, let's look back at each graph and identify the domain and the range. So it still connects to vertical asymptotes with the domain. We know that x cannot equal the first vertical asymptote. However, we'll see that every vertical asymptote happens every half of a period. So since my period is 2 pi, it's going to be multiples of pi, or half of my period, every time I hit my next vertical asymptote. And now for my range, it's going to be a little different, right? Because these u's of our reciprocals go down and then they jump and they go up. So if I look at one that's going down, I see the lowest it goes is negative infinity and the highest it goes is negative 2. Then there is a jump up to one that goes up, right? And that lowest y value is positive 2 up until infinity. So we have to look at each u, each reciprocal graph, to see the range. Here in the next example for our domain, x cannot equal the first vertical asymptote, which is pi, plus multiples of half the period, which will be 2 pi n. Now my range, if I look at one of my lower u's, it goes down to negative infinity, up to negative 1. Union with a u pointing up, which goes from 1 to infinity. Here in number 24, our domain x cannot be my first vertical asymptote, which happens at pi over 8, plus multiples of half the period, so that's pi over 4n. And the range for one of my lower u's is from negative infinity to 0, union with my upper u, which starts at 4 and goes to infinity. In number 34, for my domain, x cannot equal the first vertical asymptote, which is pi over 2, plus multiples of half the period, pi over 2n. Now for my range, if I look at a u pointing down, it goes down to negative infinity and comes up to a max of negative 1. Union with a u pointing up starts at 1 and goes up to infinity. And so every time you graph a cosecant or secant function, you should also be able to look at the graph or just look at characteristics of the function and identify the domain and range.